6.5 and 9.1119.
Yeah.
You get
The
75%.
problem.
That's 66.
Wait, no, I just want to count 3.
Because it's 8 divided by 12.
No, I'm not gonna wait.
Which is 2/3.
I was thinking
None of the data points are in there.
No, 8.
Because
that
how do you take this only 2, 10, and 10 aren't in it.
just not, you know.
But 3's not in.
Root button is right here, above your square.
So I delete it.
Yeah.
Okay.
Alright guys,
The whole other thing you did, you just like.
you should have gotten 78 divided by 12, right? 6.5. Guys, real quick. If the whole idea of standard deviation is the average distance from the mean to the data points, if I use the wrong mean, am I gonna get the right answer? Okay, so that's why you never wanna round the mean. If you must round it, you don't round it to like 1 decimal place, so. You guys kinda with me? So in a test or something, I'll give you something that's at most 1 decimal, cause it would be evil if I gave you something that's 11.4582. I don't know if you guys are kinda with me. If I change the mean, I'm changing the spread. I just am, because I'm changing the number that I'm basing it all on. So I'm gonna get the completely wrong standard deviation if I round my mean.
I have a
Okay.
question.
Yes.
These little 3 things, do we have to memorize that?
Yes. You don't, really. You really don't. Guys, what are you gonna have sitting on your formula sheet? You're gonna have this,
Oh.
correct?
Oh.
Now watch, you ready? If you have a formula and it's got a sum in it, cover it and go, oh, I need a bunch of those. Are you with me?
Yep.
So I'm gonna give you the x's. These are gonna be blank. You need to know how to create those. And you just say, what do I need? I need a bunch of x minus x bar squared. So I'll get x minus x bars, and then I'll square them. And then I can add them up at the end. Does that make sense? So now, you're going to have a lot of formulas that have this sum symbol in it. If you just cover it, you go, I need a bunch of those. Let me make them. Then I can add them up. Is that all right?
Yep.
That's all that wants from us. Poor little dude. I'm not going to write all the shit in there. And I should have put them in here, but I didn't. Oh well. I was too busy walking around. Whatever, Jeff. All right, let me see if we can catch up real quick. 2, 3, 4, 5, 6. What is it?
7.
7. Oh shit,
No.
Jeff, don't do that. 7, 8,
8,
9,
9,
10, 10. 2 overachievers. Okay. So now if I go to list 2, and clear it. List 3 and clear it. I can make list 2 equal to L1 minus. Oh
6.5.
Jesus, Jeff. L1 minus
6.6.
6.5. Bam. Okay. Now, in general, I want you to understand, do the data have to be in order for this to work?
No.
No, it doesn't have to be, so don't waste time putting it in order. I just gave us this in order just because. L3 is gonna be what I just got squared. Shabam, right? Now on a test or a quiz or homework, I need you to copy all that stuff down, obviously, right?
Uh-huh.
Don't just say, I didn't wake up. No, copy that stuff down. Now, on this, specifically on this one, I'm not going to make you do this all the time. This was 78, whoop-de-doo.
0.
How do I check this? I would go second quit,
Second list.
second stat, yeah.
Go
I want to do math. I want to sum up, whoops. And you can just hit the number 5 too, that works. I want to sum up L2. And I get 0 the way I should. That's supposed to be 0, right? And then watch this. If I just hit second enter, no, Jeff, there's too much glare here. Second enter, I can just go back and change this to L3 so I don't have to go hunting for sum again. Hunting for sum again. There we go, 75.
Wait. Can you do that again?
Sure.
How do you change it?
You can either hit second enter, or nowadays you can even hit the up arrow, hit enter, and then you're able to edit it. So I can go back and make this a different list. By the way, that kicks so much ass. Some of the equations we're going to use are going to be long. So I might get an equation that looks like 11 minus 12.5 divided by 8.7 minus 8, times 97. I don't know. And you're like, ah, shit, that was supposed to be a plus right there. Damn it. So now if you just hit second enter, you go back, make it a plus. Shabam! Okay. Day saved. Anyway, you don't have to do that, but it's there. Okay. So this came out to be a 75.
75.
Just coincidence, these are almost the same. Nothing special about that. Poor little set of data. So what does that mean? What do I put in place of this?
75.
Trick question.
Nothing.
What do I put in place of the x? Nothing.
Nothing.
Right? The x has multiple values. I can't put something in place of it. This whole damn thing is 75. N is always the size of the group I'm looking at.
Yeah.
Could be a sample or a population.
Yeah.
So in this case, it was 12. So I'm going to do 75 divided by 11.
6.818.
Okay, so let me do this. 75 divided by 11. All right? Now, if I do this, if I do square root of answer, right above the negative button, second negative, bam. 2.611. Thank you. It's too far away from you. So there it is. And this I got glare like crazy. I don't need you, do I? No. Are you guys all kind of with me?
Wait, put the glare back on.
Glare back on?
Yeah.
What?
Do you like the Star Trek movies?
I'm
Is
not
that
wearing
what
my
he does?
glasses, so I can't like see you.
Alright, how's that? Is that good?
No, it's not.
He's like,
You can't do something. We got this.
I'm sorry. I understand. When I get to the paper, I'll make sure it's there. Okay. I'm sorry. I want to show you this right now, and then some of you guys are going to get angry at me, and I don't care. Hit stat, calc, one var stats. If your calculator shows this, just make sure it looks exactly like mine. Our data is in list 1, correct? The other lists were just weird computational shit, right? Don't worry about freaky lists. I don't have a freaky list. Calculate. Does anything there look familiar?
5, the 5. How's the data?
5.
Like if you scroll down, you get the 5 over the bottom.
Oh, the 5 number
There's
summary,
your
yes.
average,
But does anything look familiar to what we did just now?
There's your sum of data points.
SX. As the movies, no, it's FX. So, do you see how the calculator tells me, what's this do?
The population.
Population standard deviation. The calculator is going to give me both because the calculator is dumb. It doesn't know shit. It has no idea if the numbers you put into it are a population or a sample. We're the humans. We know that. You got to pick the right one. So don't suddenly get excited later this semester when things are hard, when you don't know this population standard deviation. You can't go, actually, I know what it is. No, you don't. We put a sample in, right? So you can't pick this guy. Why does it give us both? Calculator's dumb. It's like human here. You do stuff. You know what's going on. I don't know. You guys semi with me? It's always going to give me both. I have to know what the hell I just put in. I put a sample in. I got to use this guy. And that's exactly what we got, yes? So I know. I am aware. Can somebody help? There's always going? Okay. Right. Good. It's always another option. I understand that you get this very quickly. For this quiz and the homework from 2-7, you must do all the work. Make the table, blah, blah, blah. You with me? Mm-hmm. Forever after this quiz, that's on 2-7 alone, forever after that, we're going to get the standard deviation directly out of the calculator like this for a list of data. Are you with me? You understand?
Yeah.
Okay. If you turn in homework and you just said, I do this in the calculator, I'm like, do it again. Show me the work. Yeah.
How'd you do the one var stat, just one stat?
Yeah. Stat, calc, one var stats. So what would this one be? The second one?
2 variables.
2 variables. So that's when I have like number of beers you drank and the grade you make on the test, right? That would be 2 sets of variables. Are you with me?
I actually do something.
All right. That's an actual example I use later this semester.
I think I've got the
That's the lecture I videotaped to give to Grossmont when I applied for a job here. I'm like, we like the fact you like beer, but
Wait, so is that you'd have 2 lists of data then, right? So you'd have 2.
yeah. All I need is, and later this semester we'll have exactly if I have somebody drank 2 beers and they got an 80, and somebody else drank 5 beers and they got a 60. That would be 2 different variables, correct? So I'd have list 1 with all the beers and list 2 with all of their grades. Does that make sense? That's later this semester. That's why we have a 2 variable statistics button. Then you got all the weird shit happening after that. That's some of that we're going to learn later. Okay. So then there's your 1 var stats. Now some of you guys, it just says 1 var stats.
Yeah.
It defaults to list 1. You just have to hit enter. For the rest of us, we got to put in here the right list. Blah, 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 blah. Okay. Okay. So, last thing about standard deviation. There is I'm going to tell you very quickly about a theorem that works for any freaking distribution. I don't care what shape it is. And then we'll talk about the one that works for this dude, right? Am I wearing the right shirt today? Yes. The one that works for a normal curve, right? Sorry? Oh yeah, we got more in this, don't we? I got all excited that we got this intervention. I guess we can finish this. Yeah, okay. So the data point is 3 for this problem here. So I want 3 minus the mean divided by how big each step is. What did somebody get for that?
Negative 1.340.
Okay. And you'll see why later. You're going to love this. I'm going to give you a z-score chart in chapter 6. And it's going to have z-scores out to 2 decimal places. But, you know, right now it doesn't matter. But later I'm going to make them 2 decimal places because it's only going to go out 2 decimal places.
Wait, you got negative 1.34?
Yeah.
That's what somebody else got.
I didn't get that.
All right, let's see. So here's one problem. Watch, I'm going to make a mistake. You guys ready? 3 minus 6.5 divided by 2.611. What mistake did I make?
You didn't tell it what order to do it.
Yeah, it's going to divide 6.5. It's not going to divide 3 minus 6.5. So I have to tell it, oh yeah, I'm sorry, calculator with no eyeballs. Those are on the top. This is on the bottom. Yeah. I'm really happy they have not put eyeballs in these things. That would be creepy. Okay. A few steps away from Skynet and all that kind of shit. Part D is going to make a little more sense when I talk about these 2 things I'm going to talk about here in a minute. But right now, you just put the mean in the middle. If I go 1 standard deviation up, where do I end up? So if I add 2611, where do I end up?
9.111.
I like it. And if I subtract
3.889.
3.889, so now the question is, how much data did I just catch in there?
8 divided by 12.
Did I catch the 2s,
No.
the 3?
No.
Capture
4.
everything between.
I did catch the 4 up through the
Up there, 9.
9. So I did not catch 1, 2, 3, 4 data points, which means I caught 8. I caught 8 data points out of 12 total,
Which is 2/3, 66%.
66.7% roughly. You guys with me? A little bit? So that's a little weird. I agree with you. You're like, what the shit's that all about? Yeah.
Can you redo it again?
Yeah, can you redo it without paying attention? It's because I had to do the calculator thing, like, because you said it has no eyeballs, so I was doing that, and then you started talking.
It's because I said no eyeballs.
I love
Sure.
the integrity.
So, start the mean, go down. I do like the honesty, it's good. Go down 1 step and go up 1 step. When I say step, I mean standard deviation. On a test, if I want a formal answer, you do not say step. When I'm just talking in general, I'm going to call it a step, right? So the steps are all this big, go up 1 standard deviation, down 1 standard deviation, that's from here to here. How many data points did we just catch between those 2? The 4 through the 9. We call all these data points. That's 8 data points. Out of how many data points?
12.
So 8 out of 12 is 66.7%.
Yeah,
Now, here's what that relates to. And I'm realizing why I'm discombobulated, because normally I would have done this before. Oh my God, how are you still going? It's got like 0.1 battery, I think. Okay. So very quickly, there is a theorem called, I affectionately call it Chubby Dude theorem, but it's Chebyshev's theorem. And it could deal with, I don't care what the distribution looks like, it could look like anything. All right, so what is this? This is like very small rectangles, a lot of data. Are you with me? This is the plot of a lot of data. So what Chebyshev says, let me make this a little more clear what this dude says. Here's the mean. If I go up and down 1 step, it is possible to catch nothing. So now does that question make a little more sense? That's a concrete example of what this says. If you go up and down one step, you catch at least 0%. So far, this says nothing useful. It's kind of like saying, how many points do you think they're going to score? At least 0. Thank you. That's really low. Way to go on the limb there. You guys kind of with me? So far, this is pathetic. At least 0% of the data. Way to go, right? I could have guessed that. Yes, everybody with me? But the minute I get out to 2 steps, and I know I drew this picture specifically, so I want you to realize, if I go out 2 steps, from the way I've drawn it, it looks like I catch some data, correct? Yes? And so one of you guys could say, no, Jeff, you could have just drawn this sucker further over here, right? If I move this data further over, what happens to the standard deviation? It gets bigger. These arrows bigger, it still catches shit. Do you understand? That's what this guy figured out, but he used a lot of nifty mathematics, mostly calculus, to figure out what would happen in any set of data ever. So if you go out 2, so this is within 1 step of the mean. So there is going to be at least, get in there, 75% of the data within 2 steps. And I do not give a shit how you set up any list of numbers you can make. I don't care what they are. I go out 2 standard deviations, I'm going to catch at least 75% of your data. That is powerful.
That's a lot.
That's saying a lot, and that is a lot. Yeah.
How'd you get 75?
That's what Chevy Chef figured out. We're standing
Also,
on the
that's like-
shoulders of
It's like a theory.
it's reality. We call it a theory. I'm not going to get into what theories mean.
It's a phenomenon.
Phenomena. Yes.
Is this a bit like, it's not the same thing obviously, but like box plots where we look at the quarter divisions and say, hey, 50% of all of our data in this particular case is with
Not quite. Ready?
Q1
The third thing, there's at least 89% of the data within 3 steps. That came out of nowhere. All right. That is for any set of data. I am not overly concerned about Chevy Chef, I call him Chevy Dude, but Chevy Chef, I'm not overly concerned. I actually have no idea if it was Chevy. I'm not overly concerned about it. I just want to kind of put that out there. Yes?
How many steps did we go right there?
1.
1, right?
1.
So how did we not, it says here you get 0%.
At
but one-
least 0%.
Oh, 0 and more.
So whatever the hell we got, it's not. So what would really be cool is if we went out 2 steps. But you see, we already got 66.7, didn't we?
Mhm.
Why? Because isn't the data sort of tight?
Yeah.
Not very spread out? There's not a lot of data points. Are you with me? So it's going to be more difficult for them to kind of like escape me. So if I could, I don't know if you guys can imagine, I could try to make a set of data where it's like so extreme that there's empty in the middle. And I'm not going to catch anything if I go 1 step out. But because I had to make it so spread out, 2 steps is always going to catch some data. In fact, what is not obvious is that it's going to catch 75% of the data. Now, if you're curious, you can Google proof of Chevy Chef's theorem. And if you don't know much calculus, you're not going to be able to get too far, right? If you do, look it up. There's some things in there I think that are a little bit beyond, but you'll follow some of it. Okay. So what is more important for us is this guy, the normal curve. If I know it's normally distributed, is it possible to go out and catch none of it if I start at the mean?
Probably not.
No probably to it. If I go at all away from the mean, am I not going to catch something?
Yes.
Is it possible for a normal curve to be empty in the middle?
No.
By definition, no, correct? What's interesting is, if I do go out 1 step, I'm going to make these z-scores. Let me see if you guys are cool with this. If I go 1 step up and 1 step down, that's positive 1 z-score, negative 1 z-score. What is the mean always, z-score?
0.
0. Z-score is how far from the mean in standard deviations? It's always 0 away from itself. This would be 68% of the data. If I have a normal curve, I will always catch 68% of the data. And to be really honest, it's like 68.26%, whatever. So these are rounded just to make it easier to remember because you're going to have to remember them. Okay. Yes.
So, on every normal distribution?
Yes.
It has to be exactly normal?
Every normal. Every normal distribution. So, could I have a very skinny normal distribution?
Yes.
Yes, so then the standard deviation will be small. I'd still go out and catch 68% of the data. Really wide. You're still going to catch 68% of the data, right?
What if you got like a slight skew? Because
Then it's not truly normal.
Okay.
It's got to be exactly normal. I like it. So a lot of what we're going to do is it's going to be called what I call normal enough. So you can assume it's close enough to the numbers from a normal distribution, but it's going to be a little off, but we can live with it, right? Okay. If I go out 2 steps, give me 2 steps now. That's going to catch 95% of the data. Which is really interesting because heights are normally distributed, right? So if I want, so can anybody tell me what percentage is out here right now? Say again? Say again. 2.5%, beautiful. How the shit did he know that? There's 95% in here, there must be how much outside?
2.5
5% outside, so 2.5 on that side. If I know the average height of people, and I go 2 standard deviations up, that's how tall I can make a door, to be guaranteed that at most 2.5% of people going through the door have to duck. So I mean, if you look at the door, aren't doors roughly about somewhere around that height?
Yes.
If we were hobbits, a lot of this room would be different, correct? The door would probably be shorter.
And Gandalf would have
Be round. Gandalf would come in. Don't give me the ring. Okay, sorry. You guys kind of with me? So a lot airplane widths of seats. How do they figure out what to make it?
They're gonna have to change that.
They count. Yes, they do. They've had to change it before. So of course, our ever expanding.
Actually, they're now weighing passengers because planes have crashed because they were using.
They
the
have to
average weight
redistribute.
of
Sometimes
one
I'll ask people to move based on weight distribution. Yes. Okay. All right. That's
No way, no.
of course, which is always great for everybody. But these things have to happen because I'd rather live. Ask me to move if I must. I'd rather live. All right. That got really dramatic. If I go out 3 steps, I'm gonna catch. Oh shit. Good.
120.
9.
More than data than you have.
I'm gonna create people. I like that.
Wait, why would it not be 100?
Theoretically, this goes forever. The only way to catch 100% is to go from negative infinity to infinity in a theoretical normal curve. In reality, something like heights. The reason that heights are not perfectly normal is because they can't go forever, especially down. Up, you could argue that we could possibly keep growing taller and taller and taller, but still, I doubt that there would be a 1,000-foot person at some point on Earth. You with me? A lot of physical limitations on that. But there's a definite limit to how short we can get. Yes? We're not going to get negative, right? I don't know, it's upside down, are you negative feet high? Yes?
Could you do it with discrete data or no?
We do. There's approximations we can make to discrete data that still uses the normal curve. We'll do a little bit of that later this semester, yeah.
Okay.
So you can start to see why we want things to be normally distributed, why we really get excited when something is normally distributed, because we know exactly the amount of data where it is. If it's not normally distributed, I only have approximations I can make. So there's a big part of statistics is knowing when you have a normal distribution, or what I call normal enough, because then I know a lot of shit. So right now, for example, could anyone tell me exactly how much is in here? From 1 to 2.
Oh, number of deviations, a percentage.
The percentage in there. So let's see.
27%.
How much is in
Oh,
here?
sorry, on the one side.
Isn't there 34% in here?
13.5%.
Because the mean cuts it in half?
Yeah, it's 13.5.
34% here. 47.5% here. You guys with me? Half of 95 is 47.5? So if I do 47.5 minus 34, I'll get how much is in
13.5.
here. All right. So you can do a little bit of manipulation of the numbers to figure out how much is where. Obviously, I can't get as specific as 1.17 up to 2.91. Not yet. That's going to be the chart that I give you later this semester. Yay, chart. Okay. I am really getting loopy, so I'm gonna cut it right there. My phone is probably dead, so that's probably good.
It's not.
It's still going?
Good phone stuff.
That's-
You bought a good phone.
That's like the fumes going on
Wait, so
fumes.
don't teach anymore, cause I rewatched those.
What?
She's like, stop it now.
I've already said I'm gonna stop teaching, so,
Yeah.
yeah.
Is it an Android?